Physicists love exposing cats to theoretical physical harm. So today I want to talk about how quantum gravity is all about dropping apples on cats. About 100 years ago, a fellow named Albert Einstein, who you might have heard of, discovered our modern understanding of gravity. Despite all the weirdness of his theory though, gravity kind of works like you'd expect it to. Apples fall towards heavy objects, or better yet, apples fall towards heavy cats. But things get a little weirder when quantum physics gets involved. Unlike gravity, which describes things that are big and heavy, like fat cats, quantum physics tends to describe small things, more like kittens. And according to this quantum theory, some unfortunate quantum kitten could be in one side of a box, another side of a box, or somehow in both sides of the box at once, in a so-called quantum superposition. For some decades now, though, physicists have been trying to figure out how to put gravity and quantum physics together. Or in other words, they've been trying to figure out how apples fall on strange quantum cats. That's the problem of quantum gravity. Most physicists, though, rather than being troubled by strange quantum cats, they've decided to turn everything into a strange quantum cat. So, in many standard approaches to quantum gravity, cats are strange in quantum, and gravity is strange in quantum. So if the cat is in two places at once, so too is the gravitational field. The only problem is that we actually never understood quantum strangeness in the first place, so we don't know if it applies to gravity as well. That's why, in my research, I've taken a more indirect approach to the topic of quantum gravity by first seeking to understand quantum physics itself. In my PhD thesis, I show how centering the concept of information can unravel many of the paradoxical features of quantum theory. Strange quantum cats are somewhat less strange from this approach. Quantum cats are not in both sides of the box at once. They're on one side of the box or the other side of the box, and which side you find the cat in is purely random. Which is to say that quantum superposition has to do with statistical information. So you ask, how do apples fall on quantum cats in our approach? Well, as it turns out, apples fall towards the statistical average of the position of the cat. In other words, right into the middle of the box. This might seem strange. The alternative is strange too. And at any rate, we should have our answer soon. Optical and tabletop experiments coming online in the next few years will be probing effects of exactly this kind. While it does seem we have to live with some form of quantum strangeness no matter what, hopefully we don't have to live with quantum confusion. Thank you.